I'm Kim Mankosa, one of the lead sales engineers here at ACT, and today we're going to talk about conservation of energy. Energy has been a hot topic in the world today with electric vehicles and batteries, wind turbine and solar, but really what I want to do is focus on conservation of energy because that's one of the biggest challenges. So today we're going to go back to high school physics on the roller coaster problem. With the roller coaster problem, we want to identify what our velocity here is at the bottom of the hill if we know our height at the top of the hill. And for that, we use conservation of energy, where your gravitational potential energy is going to be equal to your kinetic energy. So we'll write it out here. GPE is equal to KE. And because of our equations, we know our mass times gravity, which is negative 9.8 meters per second squared, times our height, which is h1 minus h0, is going to be equal to 1/2 our mass times velocity squared. Now we can cancel mass out, and we'll multiply by 2, so we know that 2 times negative 9.8 meters per second squared times h1 minus h0 is our velocity squared, then we take the square root of that, and that is what our velocity is. However, this high school problem is in a perfect, frictionless, ideal world. But we know the world is never ideal. That there is going to be friction. And what does friction do? Friction creates 2 types of energy, thermal and sound. Here at ACT, we focus on the thermal energy. So when we're looking at conservation of energy and energy problems, we want to identify the way that we can either reduce the thermal losses due to friction and other variables in the energy conversion process, or maximize the effectiveness and use that thermal loss. So this equation where we're trying to identify the velocity, whoops, I shouldn't have done squared there. The velocity would then also be minus thermal energy. So come back, learn more about ACT, and find out how we can maximize the effectiveness of your energy conversion system by optimizing the thermal plan.